Enter GraphQL, a powerful query language that is fundamentally changing the way developers interact with databases and data structures in their applications. At the heart of any GraphQL server implementation lies the GraphQL schema. This schema serves as a blueprint for the data that can be queried and manipulated through the GraphQL API. It precisely outlines the structure of queries, mutations, and subscriptions that clients can execute. Let's dive into the core concepts, starting with types and fields. In GraphQL, types represent the shape of the objects you can fetch. These include object types, scalar types, enums, interfaces, and unions. Fields, on the other hand, represent the properties of these objects. They can reference other types or scalar values, creating a network of interconnected data points. Focusing on the root types, we have queries, mutations, and subscriptions. Queries define the read operations to fetch data. For instance, you might query a list of books or a specific author. Mutations are all about write operations that allow data modifications. This could involve adding a new book or updating an existing one. Subscriptions are particularly intriguing as they deal with real-time operations. They allow clients to subscribe to updates, such as being notified when a new book is added to the database. Scalar types in GraphQL are the basic building blocks and include types like integer, float, string, boolean, and ID. These types represent the simplest forms of data. Moving to object types, these are custom types defined in the schema representing complex data structures. For example, a book object type might include fields such as ID, title, author, and published date, with each field being either a scalar type or another object type. Furthermore, GraphQL schemas handle nuances like non-nullable fields, which are denoted with an exclamation mark, and lists of types, denoted by square brackets. These features ensure the integrity and flexibility of the data being handled. Consider this example schema defined using the GraphQL Schema Definition Language, or SDL. Here, a custom scalar type, date, is defined along with object types, book and author. The schema also defines root types for queries, mutations, and subscriptions, outlining how clients can interact with the data.
This schema serves as the contract between the server and the client, ensuring both speak the same language. Step 1 in setting up a GraphQL server involves creating a new project directory. Begin by making a directory named My GraphQL Server and navigate into it. Next, initialize a new Node.js project and install the necessary dependencies, namely Apollo Server and GraphQL. Moving to step 2, it's time to define your schema and resolvers. In a file named schema.js, you'll write your GraphQL schema using SDL, or the Schema Definition Language. Here you define types such as book and author, and operations like queries and mutations. This schema is essentially the structure and rules your data will follow. Alongside the schema, in a file named resolvers.js, you implement resolver functions. These functions are responsible for fetching and manipulating the data according to the operations defined in your schema. They act as the logic behind the schema's structure, ensuring that when a query or mutation is executed, the correct data is returned or altered. Step 3 involves setting up Apollo Server. In a file named index.js, you integrate Apollo Server with your defined schema and resolvers. This setup is crucial as it brings to life the interactions defined in your schema, allowing your server to understand and respond to requests. Finally, step 4 is running your server. By executing the index.js file, your GraphQL server springs into action, ready to receive and respond to queries. Access your server through a web browser to interact with your API via the GraphQL Playground. This tool allows you to test and explore the capabilities of your API in real time. In summary, a GraphQL schema is the foundation of your GraphQL API. It not only defines the types of data and the operations clients can perform, but also structures these in a way that enhances interaction. Understanding and implementing your schema correctly is vital. It ensures that clients can interact with your data in a structured and predictable way, fully leveraging the power of GraphQL to create efficient, flexible, and scalable web applications. By mastering these steps and the concepts behind them, developers can ensure their applications are not just functional, but are also robust platforms for data management and interaction. Indeed, with GraphQL, the possibilities are as boundless as they are exciting.